Now let's study coplanar system 3D. So here we have when a particle is in equilibrium, the vector sum of all the force acting on it must be 0. So summation Fx equal to 0. So here we have the point here in 3D, and then we have F1, F2 and F3. So that is why this equation can be written in terms of x, y and z component. So here, so we can have that summation fx in I plus summation fy in j, summation fz in k is equal to 0. Okay, so in this vector equation, so we can satisfy that summation fx equal to 0, summation fy is equal to 0, summation fz is equal to 0. Like this. 0, this one 0, and this one 0. And we sum everything is equal to 0. And then these equations are the three scalar equations of equilibrium. They are valid for any point in equilibrium and allow you to solve for up to 3 unknown. Okay. Now let's solve example 3.4. So this is 3D coplanar force system. So if the whole assembly is in equilibrium, determine the tension developed in each cable. So now, how many force we need to identify? So here, we have tension in TC, we have tension in TB, we have tension in TD. So here we are given that we have weight here 300 pound. So here you must remember. So we are in 3D. So when we are in 3D, so we have here, we need to write the unknown forces in cable in Cartesian vector. Because in 3D, it is more easier we resolve into I, J and K. So must remember Cartesian means that we need to resolve in I, J and K. Because here we're going to use the summation fxi is equal to 0, and then summation fyj is equal to 0, and then here summation fk, okay, z is k is equal to 0. Okay, so this is already sketching. You need to sketch the free body diagram first, FBD. So still we ignore the connection here. Alright. So can you first you can sketch the free body diagram, and then we need to identify in Cartesian. Okay. So this is the free body diagram. So here, first, we need to identify the tension in TB in Cartesian. So here, so we have X, Y, and Z. So must remember the right-handed. So this is positive X, positive Y, and positive Z. So whatever opposite direction become negative. So now TB. So TB lies in the X direction, means that we have TBI. And then take a look the tension in TC here. So this is TC. So now we need to express TC in IJK. So now TC is given that here. So TC is given, okay, like this. So you're going to have TC here. So TC prime here. So TC, this is the angle 60 degree. So this 60 degree, so when you want to resolve the TC in Z, you can straightly use the 60 degree, right? So here, TC, you resolve into Z, you're going to have sine 30 here. So this is TC sine 60 K in Z, right? So now we need to resolve TC into TC prime because we want to resolve TC into Y and x, right? This is x. So now we're going to use this 30 degree, right? So this TC prime. So TC prime is what? TC prime is cos 60, right? So TC prime is TC cos 60. So this is TC prime. TC prime. Okay, first, you can resolve, you have resolved TC prime. So TC prime to the x. So to this x, so this is x negative. So that is why here we have negative TC prime sine 30i. Right, then we want to resolve TC prime into y. So y is positive. So that's why here we have positive TC cos 30 cos TC cos 60 times cos 30, because we want to resolve into 30 J here. So you can sum here, you can simplify here. TC Cartesian is equal to negative 0.25 I TC plus 0.433 J TC plus 0.88 CK TC. So this is Cartesian already. Okay. Next is TD. So TD here, look at TD here. So TD here, we are given the angle. Then we need to identify this angle 40 degree is belong to Z. So, and then this one 60 degree into Y. And then the last one is 120 into X. So you remember alpha, beta and gamma. So you can have here that, you can have that TD cos alpha is, alpha given 120 I in I, and then plus TD cos K 120 J here. Right, because this given is 60 into this direction, but so what is this angle? So 180 minus 60 is equal to 120. So that is for J here is 120. And the last one, TD cos 45 here. Okay, 45 degree. So you can simplify. You can have here TD is equal to negative 0.5 I minus 0.5 J plus 0.7071 K. Okay, the last one, we need to resolve the weight into Cartesian. So here negative because weight is in negative direction Z. Z. This is negative K. So student always make mistake into this negative. So must remember weight is on always downward. So that is why it's become negative 300 K. Okay, so this is the second step. In 3D, resolve into Cartesian is the second step. First step is sketch the free body diagram. Now we can apply equations of equilibrium. Okay, so the summation for all forces is equal to 0. So what we have here? So we have TBI plus TC plus TD minus 300K is equal to 0. Okay, so now we can equate into respective component I, J, K to be 0. So the first equation we have summation Fx. So we need to resolve in X component. So we resolve in X component. X means that I. So this is I. And then this is I and this is I. So this is I component. So we have TB minus negative 0.25 TC minus 0.5 TD. So this is the first equation. Okay. Next, we have J. J means that summation Fy. So we need to take only J. So here we have J. So we have 0.433 TCJ minus negative 0.5 TD. J here is equal to 0. So this is the second equation. Okay, next Okay, next we have K. So we have K here, summation Fz. So whatever falls in Z. Okay, Z we have K 0.86 here. Okay, for TC. And we have for TD 0.7071 here. So TD, and don't forget here we have K negative 300 is equal to 0. So this is the third equation. So now you can use your calculator to solve these three unknown. So you must arrange properly. So you can have, so first using 2 and 3, you can get what is the TC value and TD value, and then you substitute TC, TD, okay, into the first equation, then you can solve what is the TB. Got it? Next, let's solve example 3.5. So here we are in 3D coplanar force. And then if the whole assembly is in equilibrium, determine the tension developed in each cable. So how many force in cable here? So here we have also 3. So we have here TB. So we have TC, and here we have TD. So the first step, after you sketch a pre-body diagram, then you need to solve to express the force in Cartesian. Okay, so as usual, you get the info. So what is the info given here? That we can solve, we can express the tension in Cartesian. So now TC. So what is the TC in Cartesian? So we have TC, you can write. So you can write that. You can write TC. So your TC in this, don't forget the right handed. So TC Y, Z, and this is X. So your TC in the negative I, right? So you can write, how you can write? So let's say you can write that TC is equal to negative TCI. Okay? Alright. Okay, and then you can, okay, now we take a look at TB. So TB, so this is TB here. So TB, so what is the, how to write Cartesian in TB? So TB here is given 30 degree. So here TB lies in what component? So TB lies in Y and J. So TB don't have in Z, right? So you're going to have TB is what? So TB positive, all direction is positive, right? So I. So now we look into this X direction, I direction. So I direction, you have that TB. So here you have TB, you can have TB resolve. So sine, right? Sine 30. Sine 30 I. Plus what? Here, like this. Plus with cos 30, right? 30 J. Like that. Okay, so now the last part is TD. So TD here, this is TD. So TD here is given scale. So if given scale, you can have the what? Position vector. So now your TD, to get TD in Cartesian means that TD needs to have the unit vector, right? So you have the position here, this one AD, RAD into the magnitude RAD. So you can resolve into TD, I, J, and K. Can you do that? Okay, so here you can have, you can simplify the FB in Cartesian, and here is TC in Cartesian, and then here you have the TD in Cartesian. Then you can equate respectively into I, J, K to become here. So now you equate into respective component I, J, K. So you have summation fx equal to 0, summation fy equal to 0, summation fz equal to 0. So don't forget this one. Wait. Student always forgot to minus with this way. So by this you can use your equation, your calculator, then you can determine that what is the FC, FD and FB. Okay. Okay, now this is the last example for the 3D Coplanar force system 3.6. So if the whole assembly is in equilibrium supported by two cable at strut AD, so this is strut AD. So given 400 pound crate, so this crate is given, so you can have this W, and then determine the magnitude of tension developed in each cable and the force developed along the strut AD. So here, so if you sketch the free body diagram, so your point of equilibrium is at A, so you're going to have this is your TD, and then this is your tension in cable TB and DC. So as usual, after you sketch the free body diagram, then you have to, number 2, this is important, to resolve in Cartesian. So here, what is info you are given here for, so you have here weight, right, W. So now your W is what in Cartesian? Negative 400 K. So, and then you need to write your TD, TC and TB in Cartesian. So here you can have your TB in Cartesian. You need to have the unit vector. So you need to resolve into Cartesian. Then you need to get what is the unit vector. Definitely you can have your position vector here is what, RAB divided by its magnitude RAB. And then you can have your TC here. So your TC also you need to get what is the RAC divided by its magnitude RAC. Right. And then the last one, your TD here. So your TD here, you need to resolve into Cartesian. Also, you can have the unit vector. So you have the RAD divided by its magnitude RAD. So you can, so now you can have your point at A here become 0, 0, 0. Okay. Okay, now we consider the free body diagram at point A. So we consider here point A is equal to 0, 0, 0, 0, means that 0I, 0J, 0K, right? So this is the Cartesian. Our weight is already in Cartesian. W is equal to negative 400K. And then here we have FB here in Cartesian. And then we have FC here. And then we have FD here. Then we can equate the particle is in equilibrium, which is the all force is equal to 0 here. Then we equate the respectivity to I, J, K is equal to 0. Then we have here summation for first equation, summation Fx, okay, is equal to here. Summation Fy is equal to this, and 3 Fz is equal to this. So must remember, don't forget this W. So then you can solve that by using your calculator. This is your FB, FC and FD. Maybe in tutorial class, I will show you how to use how to solve the 3 unknown or 2 unknown by using the calculator. So here That's all for today. Hopes you can achieve the outcome of the lecture, which is you can sketch the free body diagram in 2D and 3D, and then you can apply the equilibrium equation in order to solve the tension in cable for 2D and 3D. See you for the next lecture, and then you can try to solve the tutorial in chapter 3. Okay, see you for the next lecture. Bye.